What is the blockchain, and why use the blockchain? First, let's start with a more formal definition of the blockchain and unpack it. Formally, the blockchain is a distributed and decentralized ledger that stores data such as transactions between individuals, and that ledger is publicly shared across all the nodes of its network. The storage itself consists of multiple blocks of data, chained together like the links of a physical chain. So how are these links created? Well, every block is given a unique value that looks like a random string of characters. We call this value the hash, since it's generated from a hash function that creates a unique output for every unique input that it receives. The hash is generated based on the unique data that we want the block to store. This data within the block can be anything, a string like foo, for example, or an array of numbers, or more relevantly, a list of transactions from one individual to another one. The unique hash for the block is generated not only from the data we want to store, but also more metadata about the block, such as when it was created and its position in the chain. There's also one more very crucial data point used to generate the hash of a new block. The unique hash of the last block is also used as part of the input that the new block uses to generate its hash. This means that the last block is an integral part of creating the new block's hash value. In addition, the block itself will now have a reference to the last block's hash value as part of its public data. Links from block to block are created because each new block makes a reference to the last block's value. This reference to the last block's value links the last block to the new one. And as more blocks are created, eventually we have this chain of blocks, creating the blockchain. Okay, so that's a high-level overview of the blockchain. There's still a few concepts from the original definition that we have yet to explore, so let's unpack those. First off, we have this idea of a ledger. A ledger is a record-keeping book that records all the transactions of an organization. It records contracts, payments, movements of assets, etc., so that the organization can track its economic history. As a ledger, the blockchain serves the purpose of storing transactional data. So, the blockchain is a ledger. And as we defined earlier, it's in fact a distributed ledger. So, what makes it distributed? A blockchain ledger is distributed because the ledger itself is shared with everyone using the blockchain network. In this network, multiple nodes, or rather multiple individuals, through computers connect to the core blockchain network. By connecting to the blockchain network, they each get a copy of the complete blockchain ledger that has recorded the entire history of data that is stored in the blockchain. Now that everyone has a copy of the blockchain ledger, they will get updates every time someone changes their individual blockchain as it's sent through the network. This idea of the blockchain ledger being distributed touches on the idea of the blockchain also being decentralized. Since everyone has a copy of the updating ledger, there is not one central organization with the responsibility of updating and maintaining that ledger. Let's discuss this idea of decentralization further by contrasting the centralized and decentralized models. In the centralized model, a bank holds the ledger itself and records the transactions of everyone's financial accounts. It holds all the data for the organization. So the bank, as the central organization, has all the responsibility and yet all of the power at the same time. So some might see this as a potential negative of a centralized model. Since a ledger is controlled by a single entity, they have complete authority, whether that means invalidating transactions or enacting fines that you might find unfair. However, there are some positives to the centralized model, since the bank can perhaps give you incentives to join their system, or they can give you reward points for using your credit card and insurance policies in case your items get lost or damaged. Still, in this system, you completely trust that central entity in order to record all of your transactions. On the other hand, the decentralized model is trustless, which counterintuitively means you trust the decentralized system itself, and in a way, you can trust it even more than a central organization. Everyone has equal power and access to the history of transactions in the decentralized model. And furthermore, everyone has the responsibility of recording these transactions. So the system is fair and transparent, and the record of transactions is not kept behind closed doors. You don't trust one organization to manage the data. Rather, you trust the system itself, since you don't have to trust anyone. Finally, let's continue answering this question. We've already started answering it a little bit, but let's ask again, why use the blockchain? So, as a distributed and decentralized system, it's trustless, in the sense that you don't place all the power of recording transactions within one organization. Now, this also means we eliminate the necessity for third-party intermediaries and middlemen to handle our transactions that could enact fees for their services. In the blockchain network, two nodes can trade with each other directly without having to rely on a bank or an accountant to officially document the transaction. Given the nature of the decentralized system, the blockchain is also highly secure. There is not one central point of failure. A hacker that is trying to take down a bank needs to only take down that one bank in a centralized system. In the blockchain, the attacker needs to take over thousands, if not millions, of nodes and computers to hijack the network. This also makes the system very dependable. With all the nodes of the blockchain network recording transactions, you can trust that your data is present, even if your own connected node temporarily goes down. Overall, we now have a better grasp of the blockchain and its definition. We understand what it means when we define that the blockchain is a distributed and decentralized ledger that stores data, such as transactions between individuals. And we know the great benefits of that ledger being publicly shared across all the nodes of its network. Next up, let's explore the main ways that blockchain technology is being used today in order to revolutionize the world. So far, we have explored two aspects of cryptocurrencies, the blockchain and wallets, that give the blockchain additional security through digital signatures. For the third aspect of cryptocurrencies, which relates back to the blockchain itself, since many blockchains also have this feature, we have mining. Through mining, miners do the work of adding transactions to the blockchain. See, when people submit transactions to the cryptocurrency blockchain network, it takes a little time for those transactions to be confirmed and added to the blockchain. When transactions have been sent to the network, but not included in the blockchain yet, we call those transactions unconfirmed. Miners then take a group of these unconfirmed transactions and include them within a block in the chain. The actual act of mining is done through solving a computational puzzle called the proof of work algorithm. This proof of work algorithm is difficult to solve. There is a low probability of randomly solving this puzzle, so a lot of trial and error is required to find this answer to the proof of work algorithm, which is time consuming and computational expensive, which is why it's called mining. So once the miner solves the proof of work algorithm, they gain the rights to submit a valid block containing the transactions to the blockchain. Once the miner submits a solution to the proof of work, other miners can see that solution, since this proof of work algorithm will be easily verifiable once another miner has presented the solution. So with this agreed upon verification, miners in the network can include a block of transactions to the chain. Now, why would a miner go through the trouble of solving this computationally expensive proof of work algorithm and problem and do the mining at all if it's costing them money with electricity and hardware requirements? So as a reward for doing the task of mining, the miner receives some cryptocurrency. Thus, miners are continually trying to mine new blocks in hopes of gaining this currency reward, which provides a system where transactions are added to the blockchain. This also gives the cryptocurrency control over the rate at which new blocks are added to the chain and how many transactions come in at once. By making this proof of work algorithm more difficult, they can slow down the capability of miners to add new blocks to the chain. Likewise, if blocks aren't coming in fast enough, they can make the proof of work algorithm a little easier, therefore speeding everyone's mining ability up. Now, you may have heard of mining rigs, which are essentially supercomputers with very powerful hardware designed with the sole purpose of mining blocks for cryptocurrencies. The goal is to rack up these mining rewards as a way to generate real profit. In all this talk of cryptocurrencies, the big elephant in the room left to discuss has yet to make its entrance, and that elephant in the room is Bitcoin. Bitcoin is the face of cryptocurrency today and was the first decentralized cryptocurrency created back in 2009. Its main features are those mentioned previously: the backbone of the blockchain, wallets with private keys and public keys for signatures, and it has a mining system with rewards with a proof of work algorithm. As more and more people around the world are starting to gain awareness of these revolutionary blockchain technologies, more and more people have started to invest their resources into Bitcoin. As of early 2018, a single Bitcoin is worth around $10,000. Just at the start of 2017, one Bitcoin was $1,000, and the year before that, at the start of 2016, it was around $400. So clearly, cryptocurrencies and blockchain technologies are on the rise. Now, beyond Bitcoin, there are many other cryptocurrencies that are taking the world by storm. Notably, there is the Ethereum blockchain and cryptocurrency, which has the second highest value for a cryptocurrency right behind Bitcoin. And not to mention, there's Litecoin, Ripple, IOTA, and thousands of others to mention, which have other aspects in addition to the core technologies of Bitcoin. But they all implement a blockchain, and for the most part, have the same core concepts of mining to support them. So, as blockchain technology itself is an innovation separate from cryptocurrencies, the applications for the technology are truly far-reaching and almost endless. Blockchains can also be leveraged to support fair and transparent voting systems. Some see the potential for the identification of individuals through documentation systems on the blockchain. Now, skeptics of blockchain technology will mention that the system is too complex for widespread adoption, and perhaps that humans are too attached to existing systems of transaction, such as modern banking, in order for blockchain technology to truly change the world. But years ago, the same was said for the internet, and it was met with the same amount of skepticism, as people predicted its total failure in the early 90s. And now it's impossible to imagine the world without internet. So perhaps in about a decade or so, it will be impossible to imagine the world without blockchain technology as well. Overall, blockchain technology is poised to continue revolutionizing the ways we interact with systems based on trust, especially economic systems. Therefore, to be best equipped to succeed in a blockchain-based future, what better way than to build our own blockchain and cryptocurrency?